Welcome everyone. My name is Zanta with Repro Products, and this is a screencast video on how to create a structural truss. Here I am in Revit 2016. I'll click New under Families and scroll down until I get to Structural Trusses. We'll start from this particular family, and we will go ahead and build our truss. We want to go ahead and create a couple of reference planes here. We'll dimension them so they are equidistant from the center and place a dimension at the bottom, and we'll specify this particular dimension as a parameter, and we're going to call that top chord length, and we'll create it as an instance parameter in case we need to make different sizes. We'll also go into the family types window and change that to be a formula such that it's the truss length divided by 3. Hit OK, and it will make the adjustments. We need to create a diagonal line for the top chord from here to here, and one from this intersection down to here, roughly about 4 feet. So I'm going to go ahead and use the reference plane command again, and place one up here. That way I have intersections that I can use to snap to. I'll use the top chord command. I'll click at that intersection and click at this intersection. I'll go ahead and place another one here, and then place one here as well. Now, depending on how you create these chord lines, you may or may not get the lock icons, and you may not be able to click them in time. So you can use the align command to align and lock. You can also just select the object after the fact, drag out, drag back in till it hits, and then lock it. You'll want to do this on both ends, so that way everything flexes properly as you are making adjustments to the design. And so it looks like this one is locked as well. So we'll go over to this side, pull this out, and pull it back in. And it's locking by default, which is good. And we'll select this end, pull it out, pull it back in, and lock this end. Now that we have the top chord created, our next step is to create the bottom chord. Go back to the Create tab, click Bottom Chord, and draw one from this end to this end. And verify that you've aligned and locked it accordingly. The other thing too is aligning and locking just a horizontal is one thing, but the ends also need to be double checked. So if I pull this back out, pull it back in, I can verify that it's locking. If you don't do this, then a lot of times the truss will break on you. So we're going to pull this out, pull it back in, and verify we have the locking still, which we do. Good. You'll also notice as well that the top chord is pink and the bottom chord is blue. We'll go ahead and create the dimension for the end height for the left and the right. So I'll place a dimension from that plane to tabbing to that point and placing the dimension. I'll go ahead and select that dimension and parameterize it and call it end height left. Hit OK. And then do the same thing on the other side. And parameterize this one as end height right. And right now I have them set as type parameters, which we'll double check a little later to see how that gets affected. We want to go ahead at this point to create the webbing that we need, the vertical webbing and the diagonal webbing that's inside. So we're going back to the Create tab of the ribbon. We'll go ahead and use the Web command, and we'll work our way from the left and go to the right. So I'm going to draw one from this endpoint to this endpoint and locking. Again, I'm going to select it, pull it out, and pull it back in, and verify it's locking, which it is. You'll want to create two more webs from here to here, another one from here to here roughly, and then one from here to here, and then lock. The webbing that's in between here, we need to set to be equal. So I'll place a dimension string from that plane to that line, and then to this plane. And we'll place it here, and we'll click the equal symbol, and it will adjust it accordingly. We need to create another web member here, going up, and as well, we need to dimension from that plane to that line to that plane and set it as equal as well. Now a lot of people, since the truss is going to be identical on the other side, they like to mirror it. It's usually not a good practice to do this, and the reason is because when you do this, it'll break the geometry. It's best to go ahead and draw it accordingly. So we'll go back to the web command, and we'll draw from that endpoint to this endpoint. It's locking. There's that end is not locked. Now it's locked. So be very careful. Sometimes the icon is very difficult to see. The green ones that I drew in the middle are initially just now. Again, you don't have to worry about the exact location of the drawing of it because you're going to use your dimension string to use an equality condition. And then lastly, the web command again for the one that's in here. We'll place the dimension and use the equal symbol. Now that we have all of this created, let's go ahead and double check to make sure that what we drew is clean and it makes sense. Now, we also have the diagonal lines, the diagonal web members as well. So let's go back to the Create tab and click the Web command. Click that end to this end. And they should lock by default, and it does look like it's locking. I'll do the second one from here to here. I'll do the third one from here to here. And then for the ones that are in the middle, oh, I forgot. We have one more web in the center. Forgot to draw. So let's place one right there and lock that as well. And then we'll draw from here to that point. And then from that point to here. Again, don't mirror it. It's safer for you to draw from one end to the other. And it doesn't take that long. This ensures that you're creating it properly, that the lines and the ends of the lines are snapping correctly to its positions. And if you have to zoom in, so you hit that intersection just right. Now that we've gone ahead and created all the webs, we want to go ahead and flex the geometry to verify it's functioning. So I'm going to save the work real fast. and I'll put it under, say, C temp, and we'll call it custom truss. We can then go ahead and go into the family types window, and we can make some basic design changes. For example, let's make this 6 and 6. Let's make the top chord length as a formula based upon the truss length, so we'll change the truss length to say 60 feet, and we'll change the height to say 9 feet. We hit apply, and and there we go. We have a situation where it wasn't drawn properly, and it says the constraints are not satisfied. So let's see. Sometimes you can select within the error, and it should highlight where you're having issues. Sometimes it doesn't. We'll just go ahead and remove the constraints, hit apply, hit OK, and let's see what happens. So we have this dimension and this dimension that is not functioning. So we're going to take this reference plane out. And what else? Top chord length is 20 feet. Scroll down. Top chord length should be truss divided by 3. That's 60. Yep, that's okay there. And let's set this to 3 and 3. Hit OK. Now we'll go ahead and parameterize this as the end left height of 3. And this one is end right of 3. Save the work again and flex it again. Oops. Let's scroll down. Let's set this to 80 again. Set this to 10. Change this to 4, 4, and apply. And again, the constraints are not holding, so we'll have to remove those constraints and hit OK. So if I were to delete this 3 foot and this 3 foot, go back in here and get rid of my end height left and end height right, and then just flex with what we have. Does it adjust? Yes, it adjusts. So we have to figure out in another exercise or time why we can't place a dimension string that defines the endpoint of this top chord here and here that defines its position. It's just a little bit of homework to do, that's all. So for the essence, that's it. That's how you create a custom truss in the Revit software. Now, how do we use it in a project? We have it saved right now as custom truss. I'll start a new project based upon, say, the structural template. I'll control tab back into that truss family, and I'll load it into the project. And then I'll just draw it from one end to another. If we look at this in 3D, we should be able to see it. We shade it up, and you can see what's happening. Now, why did it choose to have the wide flange profiles being used? If I select the family and go to its type properties, you'll see that you do have the ability to force it to be a particular framing type. And since in this default Revit family, in this default Revit project, they only have the W shapes available, it just went ahead and defaulted to using them. Okay. There are some other ones, however, you can force it. So let's say we go in here and we make it this concrete rectangular 16 by 32. Hit apply, hit OK, and it adjusts accordingly. Oh, we forgot to do the very bottom chord. So let's select that member again. Scroll on down, and we'll set this on as well. Now, if you load in all of your structural members first, you'll have a longer list to pick from to change. So let's say, for example, I go under structure, and I say I need to put in a beam. I can load other beams. So we'll go to structural framing, steel, and we can change our visibility to thumbnail and get an idea of what we're working with. So let's pick this double angle here just for fun. And we'll pick a particular size that makes sense, maybe something not big. Let's see. Let's try something like that. Now that it's loaded, it's in the project, I can go ahead and go back to that custom truss family, and I should be able to see inside here the double angle. And we'll pick it. And let's just see how this looks. And there you go. That's how you create a custom truss in Revit and use it in a project. Thank you very much for watching, and this is Zon from Repro Products.